Good day, ladies and gentlemen. You are all welcome to lecture number 3 on Buad718, which is Computer in Organization. In our lecture number 1 to 2, we have covered items number 1 to 6 from our 14-point agenda. And today we are going to proceed from item number 7. And this item is on data transmission in computer. We're going to see how the transmission takes place, the nature, the speed, and the error detection pertaining to transmission of data from one computer to another or from one point to another within a computer. And the first thing we need to understand is that we know we use input devices to deliver data into the computer, and such input devices include keyboards. Okay, if you have a keyboard connected to the computer, all you need to do is to be pressing buttons so that the data is transferred into the computer. But what we need to know here is that when you press 1 or when you press letter A or B, you should know that the computer don't understand those letters or those figures you're typing using the keyboards. What it understands is that it understands zeros and ones, because we said computer is a digital device, therefore it deals with zeros and ones, binary number system. So what you are doing in essence is that whichever button you have pressed, you are like encoding the data in such a way that it will be transferred or changed into series of zeros and ones that the computer understands. And how we do that? We use the method we call interchange of information. That is how to change from our human readable data into the computer readable data in binary zeros and ones. And of course, there are different ways of doing that encoding. And sometimes all the characters we have on the keyboards, sometimes we change them into 7-bit binary number, and in some method of encoding, they are changed into 8-bit binary number depending on the type of encoding used. One of the most commonly used methods of encoding data in computer is called ASCII, and this ASCII is an acronym for American Standard Code for Information Interchange. And this ASCII, it takes care of all the normal alphabets we have, that is from A to Z, both the capital letters and the small letters. It also takes care of the numeric values, that's from 0 to 9, and also punctuations like commas, question mark, exclamation marks, and what have you. And all this, if you combine them together, they are known as printable characters, because if you press A on your keyboard, you will see it on the screen. And of course, it takes care of other characters which are known as non-printable characters. That is, if you press them, they don't appear in your writing. For instance, if you press a control key or if you press a shift key on your keyboard, you will never see it appear on your monitor. Yes, on the screen. And those characters are called control characters because they don't physically appear in the typing you're doing. Now, let us look at this ASCII. As we have mentioned, it is method of encoding data in such a way that we use 7-bit of binary data. And if you look at this table, you see that we have columns here, and in each column you see a series of bits. Here we have 0003 of them, here we have 001, and in each one you can see that we have 3 bits. These are our columns. And if you come to this side, you see the rows, and in each rows we have 4 bits, like this one 0000, the next one is 0001, up to the last one that have 1111. So what we are saying in essence is that supposing you press this letter P on your keyboards, what you are doing is that you are encoding it in such a way that this P will be changed into 7 bits binary number. And how does it do that? It will go to the column under which the peoples, and on that column you can see that I have 101, and also it will go to the corresponding row, and you can see that it is under 0000. Therefore the binary equivalent for this P should be 101, then followed by 0000. Likewise, if you press letter W, for instance, it is under the same column 101, but it is under this row where I have 01111. In the same way, if you decided to press something like question mark, look at it here, press question mark, you see that we have 011 on the column, and the corresponding row has 1111. So in the same way, whichever of these characters you pressed, you can find the binary equivalent from this ASCII code table. For instance, if you press the figure 8, number 8, see it is under this column, which is 011, and the corresponding row is 1000. So this is how the data is transferred into the computer. It will accept it in the raw form. We understand alphabets, numbers, and the other punctuations, but the computer don't understand those ones. Therefore it has to change it into series of binary bits, that is series of zeros and ones. Now let us go to the definition of what is data transmission. Actually, data transmission is nothing but the movement of data in form of bits, that is series of zeros and ones, between two or more than two digital devices. Whenever you are sending data from one digital device to another one in form of this binary bits, then you are transmitting the data. And this transmission of data basically takes place through some transmission medium. What we mean by transmission medium is the channels through which the data moves. Sometimes we use wires, and of course there is even wireless transmission channel. And for the wired transmission channels, we have cables like what we call coaxial cable, and of course we have what we call a fiber optic cables, and many more examples. Now we look at the types of data transmission. What are the different types of methods through which data is transmitted from one digital device to another? So this is given in this block diagram. It is telling us that the data transmission has two types. Basically the main two types are the parallel data transmission and the serial data transmission. These are the divisions. But under this serial also we have two types. We have synchronous means of data transmission, and we have what they call asynchronous means of data transmission. Now let us start with the parallel data transmission methods. What we mean by saying that the data is transmitted in parallel is that all the bits of the data, all the bits contained in that data, they are transmitted simultaneously. That's at the same time, each bit on its separate transmission line. For instance, if you have a data that contains n bits, this n can be any number. Like in ASCII, we use 7 bits. So therefore, if you press A using ASCII method, you are producing a 7-bit of binary numbers. So whenever you have n bits of binary numbers, then we need n wires or n lines for that data to be transmitted, because we said each of the bits is transmitted on a separate transmission line. So all these n bits of one group are transmitted with a single clock pulse. What we are saying is that the oscillator that is working for the data to transmit from one place to another, whenever it takes once, then one set of data is transmitted, another tick of the clock, one data set is transmitted. And basically this parallel way of transmission is used for a short distance communication. It is not used for transferring data over a long distance. It is used for short distance. And for us to understand this, let us look at this block diagram. Here we have our sender, and it is sending, let's say, this set of binary numbers 11001010, and we need to transmit this data from the sender to the receiver. So we count. Here we have 8 bits, therefore we have to have 8 wires: 1, 2, 3, 4, 5, 6, 7 and 8, and each of these bits will be transmitted on a separate transmission line at the same time, and that is the reason why we call it a parallel mode of data transmission. So, having seen what a parallel method of data transmission is, let us look at the advantages and disadvantages of this method, if any. So, pertaining to advantage, this way is very fast, it's very speedy. The reason is that we use multiple wires to transmit multiple bits at the same time. We don't need to send them one after the other. So since they are transmitted at the same time simultaneously, it means it can be transmitted at a very fast rate, very high speed. So this is the advantage. Pertaining to the disadvantage of this parallel mode of transmission is that it is very expensive. It is costly method. The reason is, whenever you have n bits you want to transmit, then the number of lines that will transmit the data must be equal to the number of bits. Just like in the case we have just seen, we have 8 bits and we need 8 wires for that transmission. So the more the number of wires, of course, the more the cost of the transmission. This is the disadvantage of this method. Then if we come to the second methods under the main heading, we have what we call a serial type of data transmission, and in this case the bits of the data are transmitted serially. By serially we mean they are transmitted one after another with single clock. That is, whenever a clock pulse tick, one bit is transmitted, another clock, another bit. For our case where we have 8 bits, it means we need 8 clock pulses for those 8 bits to be transmitted from the sender to the receiver. And if you look at this, it means we need only one communication line. Yes, because only one bit is transmitted at a time, therefore we need only line that will be transmitting those bits one after the other. And how the transmission starts is that the least significant bit will be transmitted first, and then the most significant bit will be transmitted last. Let me explain what we mean by that. If you look at this data here, you can see that we have 11001010. The one we have at the end of the right hand side, 0 here, is called the least significant bit, followed by this up to the one we have at the end of the left hand side. It is called the most significant bit. So when we are transmitting this data, this 0 will be transmitted first, followed by this one, followed by this 0, followed by this one, up to this last one, which is the most significant bit. And for us to do that, you can see, if you look at this diagram, our data exists as a bunch of what? Bits, 8 of them, and we said we want to be transmitting them one after the other. So for you to be able to do that, you need another device. The device is called parallel to serial converter, and this parallel to serial converter is a device that will now separate the bits in such a way that they can be transmitted separately, because before that they are like a one block of data. So after using this parallel to serial converter to change the data from the parallel pump to serial, then it will start sending them one after the other. As I told you, this 0, which is the least significant bit, is transmitted, followed by this one, followed by this 0, followed by this one, up to the most significant bit, which is 1 here. Now when it reaches the receiver, they come serially, that is one after the other. So we need another converter which will change them from the serial form to the parallel form, so that the receiver can understand the data transmitted to it. Now, what are the advantages of using serial means of data transmission? The basic advantage is the reduction in the cost. Because as we have seen here, we transmit the data bit by bit. So therefore we need only one transmission line to transmit any number of bits. So therefore the cost of the transmission line has been reduced. And concerning the disadvantage of this method, first of all, there is need of conversion, as I have shown before, that if you want to transmit data from the sender, you need to use what we call parallel to serial converter. And when this data arrive at the receiver, we need another device that is called serial to parallel converter. So the cost of these converters increases the overall cost of the methods of transmission using serial mode. And also another disadvantage is the fact that it is very slow compared to the parallel. The reason is simply because we transmit the bits one after the other. This first bit must be transmitted, followed by the next one. It will take a longer time before you transmit all the bits. Therefore, these two are the disadvantages of the serial mode of transmission. And also, as we have seen on our block diagram, the serial mode of transmission is also divided into two. Number one is called synchronous mode of transmission, and the other one is called asynchronous type of data transmission. And both this synchronous and asynchronous, they use what we call synchronization bit. What do you mean by synchronization bit? This bit is like a data that is used between the transmitter, and that's the sender, and the receiver, so that they will be communicating with each other to know that to know that the transmission of data has started from the sender, and to know when the transmission has ended. Therefore, this bit synchronization, its function is to tell the receiver and the sender that okay, we are starting sending the data now, and when the data sending has been concluded, that bit will tell both of them that the transmission has come to an end. Therefore, the function of this bit synchronization is to provide a timing control, that is to determine the time when the transmission starts and the time when the transmission has come to an end. Now let us start looking at them one after the other. We start by looking at asynchronous transmission type. And this asynchronous transmission type, it sends only one character at a time. If you can remember, I told you these characters, they are encoded in what we call a byte, and each byte is equivalent to 8 bits, that is series of zeros and ones. 8 of them will give you 1 byte. So this character we are talking about, it can be a letter alphabet like A, O, B, O, C, uppercase or small case, and also it can be a number like 1, like 0, like 9, like anything. And of course it can be what we call control character. The control characters are the characters that don't print on the screen when you press them on your keyboard, like control key, like shift key. All of them, if you press them, they will not appear. This bit synchronization between the two devices in asynchronous mode, its function is to show that the data has started coming and to show that the data has stopped coming, it has reached an end. Therefore we have 2 bits. 1 bit is used for showing the starting of the transmission of data, and the other one is used for showing the stopping of the transmission of data. This start bit alerts the receiver. It tells the receiver to the arrival of new group of bits, and we use 0 as our start bit. That is, before the transmission starts between the sender and the receiver, you send synchronization bit, which is 0. The moment the receiver sees this one, it will now be ready that a data is coming. Then when the data has finished going, then it will send the stop bit, which is usually 1. The moment it sees this one after receiving the main data, it knows that yes, this character has come to an end. Then it will wait for another start bit, which is 0, to tell the receiver that yes, new signal is coming, and the next one should give us the end of that. And if you look at this diagram, it is clearly indicated. This is our 8-bit data, and if you look at it, I have 11, 01, 01, 10, 8 of them, and this is the same thing as 1 byte, that is 1 character. Now if you are sending this data from the sending end to the receiver, all you need to do is to first of all send this 0. When the receiver sees this 0, it knows that data is coming. Then after the 0, these ones will be received and grouped as 1 byte or 1 character. After them, the sender will send this 0 to tell the receiver that yes, the data has been transmitted completely and you should stop. Now, what we need to understand with respect to this method we just illustrated is the fact that, you see, apart from this 8-bit of data, which is the actual useful data we are sending, we included a 0, which is our start bit, and we include what? 1, which is the stop bit. So we need to know that the start bit and the stop bit, they consume more bandwidth. By bandwidth, we mean they consume more space of the data transmission, because they are useless, but their important is to tell the receiver that yes, the data has started coming and the data has stopped coming. And another thing concerning this method, these are like disadvantages, is that there is a gap between one character and the next character, because whenever you send your 0 to alert this receiver that the data has started coming, then you send your data, then send a 1 to show it that it has come to an end. Then it is after this that you will send another character. Therefore there is gap between one character and the next, and that gap is also causing a delay and waste of space. Now, concerning the applications of the synchronous transmission methods, one of the areas of its application is that it is very suitable for the keyboard type terminals. Yes, whenever you are using a keyboard to transfer data into your computer, you know that you press one key after another. No matter how fast you are in typing, you cannot press 2 keys at the same time. It will report an error. It has to be one key after the other, one key after the other. Therefore, we can see that each character is transmitted separate from the other. Therefore, this is very similar to asynchronous mode of transmission. And of course, this method found application in traffic, which transmit a short burst, that is, short bit of information, then another one, then another one, like in internet. Because in internet, you know, you have to send your search request, then the browser will take it, search the result and bring it back to you. Therefore, you are sending your information bit by bit and you are receiving the result bit by bit also. And this type of transmission, that is asynchronous, it is used in what we call modems. This modems is an acronym of modulators and demodulators. The most commonly known modem to all of us here is the modem we use for browsing. It is called modulator, demodulator. Explanation to that is not for your consumption. Now, what are the advantages of asynchronous transmission mode? Number one, it does not require any local storage at the terminal or at the computer. What we are saying here is that when you are sending data from the receiver to the from the sender to the receiver, you don't need to provide any means of storing the data at the receiving end. No, whenever they come, they are accepted and delivered directly into the receiver. And also, this method is cheaper when we compare it to the synchronous mode of transmission. What is the reason that make it very cheap? Is the fact that it is used in short distance transmission. Therefore, the lines that are required, they are not that very long. Therefore, the cost is very small. And another advantage is the fact that since the bits are transmitted one after the other, characters one after the other, so when one character is corrupted, that is, it has an error, the others will not be affected because they are different from one another. And of course, another advantage of this method, that is asynchronous, is the fact that it is possible to transmit the signal from source to the destination that have different bitrate, that's different speeds, because there is no need of anything like synchronization. And of course, it can start as soon as your data you want to transmit is available. You can start sending the data. The reason is simply because we don't need to align the two systems. You can just transfer anyway. And of course, this method is very easy to implement. The reason that makes it easy is the fact that there is no need of timing to have accurate timing between the sender and the receiver. And this is a typical block diagram showing, or typical diagram showing the synchronous transmission mode. This is the sending computer and this is the receiving computer. It sends this character with the start bit and the stop bit, then there is a gap between them. Then it will now send another character with start and stop bit, there is a gap between them, and next character like this. Now, what are the disadvantages of the asynchronous transmission mode? One of the disadvantages is the fact that it is slower. What makes it slow is the fact that we have extra bits that are used for telling the transmitter that this is the start and this is the end of a character. And of course, as we have seen from the previous diagram, there is a gap between one character and the next, and this is the reason why the method is comparably small and slow. And the disadvantage number 2 is the fact that these start and stop bits, they can be missing. As you are transmitting data from the sender to the receiver, you can lose your stop bit and start bit, and if that happens, then the receiver will not know when the when the character is started coming and when it ends coming, and definitely it cannot understand the data sent to it. Now, having seen that, let us move to the other methods under the serial, which is synchronous transmission mode. And this synchronous transmission mode is the one that does not use start or stop bits. There is no need of those things. And the bit stream is combined into a longer frame of multiple bytes. As you can see from this diagram, from here to here we have 8 bits, which is 1 byte, another 1 byte, another 1 byte, another 1 byte after this, and all of them are joined together. We don't have any start bit, we don't have any stop bit, and there is no gap between one bit and the other. Therefore, if you look at this method, we can say that yes, the spaces that are lost when we add start bit and the stop bit in case of asynchronous, they don't longer exist, and also the gap that is created between one character and the other is also eliminated. Now, this synchronization is by the same clock. What we mean by the same clock frequency is that the rate at which this sender is working it must be at rate the speed at which the receiver is working, so that they are moving at the same time with the same frequency, so that they can understand one another and receive the data and send it correctly. The receiver, when the data reach the receiver, it is the receiver that has the ability to now recognize that, okay, from here to here is 1 byte, let me take it. From here to here is another byte. It is the one that has that responsibility to separate the bits that went to it and now reconstruct them into different characters. And what makes this thing possible for the receiver to do that is the fact that they are synchronized, they are communicating with one another at the same time and at the same frequency and the same speed. Now we are at the areas of application of this synchronous transmission mode. The synchronous transmission mode, we use it whenever we need a very high speed communication between computers. Yes, because you know that there is no waste of what space for including the start and stop bit, and also there is no gap between one character and the next, therefore the speed is very high. And the advantages of this one is the fact that it is faster. The reason why it is faster because we don't have any extra bits like we have in the asynchronous start and stop, and also there is no any gap between the character and the next. But despite this advantage, it also has some disadvantages. Number one, it is very expensive when we compare it to asynchronous mode. The reason that make it to be very expensive is the fact that we need accurate timing between the sender and the receiver, and also it requires a local buffer. This local buffer means a temporary storage area that will be receiving the data from the sender to the receiver and keep it there before the data is now separated into different characters. And as I told you, another disadvantage is the fact that it needs accurate timing, accurate synchronization between the clock of the sender and that of the receiver. And this accurate timing of course leads to the increase in the overall cost of the system. And lastly, it requires proper synchronization. And for you to get this proper synchronization between the sender and the receiver, it makes the system very complicated. So these are the disadvantages. And if you look at these tables, they are just trying to give us the comparison of what we have just seen. Here we are comparing the serial and the parallel. We are looking at the factors like this factor is the number of bits transmitted at one clock. We know that for serial we transmit 1 bit per clock, but for the parallel we transmit all the bits, n bits per single clock. We have seen it. This table is just like a summary of what we have seen. And concerning the number of lines required, for the serial we need only 1 line because we transmit it bit by bit, but for the parallel we need n lines because all the n bits are transmitted at the same time. And if you look at the issue of speed of the data, the serial is slow and the parallel is fast because it transmits all at the same time. And if you look at the cost of transmission, this serial has a low cost because it transmits one after the other, but for the parallel the cost is very high because we need n lines for n bits. And for the application, this serial is used for long distance communication between computers, and the parallel is used for short distance communication. We have just seen all this, but we are just like giving a summary of them. And now if you come and compare the synchronous and asynchronous under the serial mode, you will see that concerning the data sent at one time, here we send 1 character, 1 byte, but here we send multiples of bytes. And concerning start and stop bit, we use it in asynchronous, but we don't use it in synchronous mode of transmission. And concerning the gap between one character and the next, is it exists in asynchronous, but it doesn't exist in synchronous mode of transmission. And concerning the speed of the transmission, in asynchronous it is very slow and in synchronous is very fast. And if you look at the issue of the cost, The cost is very low in asynchronous, but it is very high in synchronous, and we have mentioned the reasons why. So now we are done with the types. Remember, we are done with the types of data transmission. Now we are going to start looking at, as we are saying, what we have seen so far is what we call types of data transmission. We have two types basically, serial and the parallel, and under serial we have synchronous and asynchronous. And here is another classification, and we call it data transmission modes. The other one is types and this one is modes. And if we say mode of data transmission, what are we saying? We are saying the way in which the data is transmitted from one place to another. And with respect to that, the data transmission mode is also known as data communication mode or the directional mode. Therefore, this mode of data transmission, it is trying to tell us in which directions does the data move. Is it in one direction? Is it in two directions? Is it at the same time? Is it at alternate times? And based on that, we have three modes of data transmission. The first one is called the simplex mode, the second one is called half duplex, and the last one is called full duplex mode of transmission. And if you look at the first one, which is the simplex mode of data transmission, we define it as the mode in which the data can flow in only one direction. It can flow only from the sender to the receiver, but the receiver cannot send back data to the sender. And a sender can send the data, but he cannot receive from the person he sent to. And at the same time, the receiver can only receive the data, but he cannot send back to the person that sent to him or any other person. Look at this block diagram. Typically, this is our sender and this is our receiver, and you can see the arrow is showing that the data is transmitted from the sender to the receiver only, but the receiver cannot send back to the sender. And this is what we call the simplex mode of data transmission. And if you look at this one, it has some issues. First of all, it is not possible for you to confirm whether the data is transmitted correctly or there is an error. You cannot. The reason is simply because the sender can only send data, but he cannot receive. He can only send data, but he cannot receive it from the sender. Okay. And another issue is that it is not possible to request for the resend of the data in case an error is detected. You understand? If we find out that there is an error in the data sent, there is no way that the receiver will now send back to the sender and tell him that please transmit the data again to me because the one you sent, there is an error. The reason is simply because there is no feedback channel. And the examples of this simplex mode of modes of data transmission include the radio broadcasting. The radio station just broadcast out for the receivers, but the receivers cannot send back to the transmitters. And also the same thing to television transmitters. They will send, but they cannot receive from their receivers. And another example of this simplex mode of data transmission is the data sent from the computer to the printer. Always when you are done with your typing, you want to print, you can send the file to the printer for it to print for you, but the printer cannot send back information to you. It can only receive. So that is what we call the simplex mode of data transmission. The second one on the list is the half duplex mode of data transmission. And this half duplex is a method or is a mode of data transmission that the data can move in both directions. That is, it can move from the sender to the receiver, and the receiver can now send back to the sender at the same time. But the limitations to this is that it can flow in only one direction at a time. That is, if you look at this diagram, this person can send and can receive. The same thing, this person can also send and receive, but when this one is sending, the other person cannot send at the same time. It has to be that after this one has sent this one, then this one can now send, but they cannot send at the same time, and that is the reason why we call it half duplex. A typical example of this half duplex transmission is in internet browsing. When you are browsing, you send your requests on your browser, then the browser will take it and search the information for you and then bring back the results, but it cannot be receiving and sending at the same time. Now we come to the full duplex. The full duplex, on the other hand, is the one in which the data can flow in both directions and at the same time. That is, this person can be sending and be receiving at the same time, and this person also can be sending and be receiving at the same time. There is no need of one to wait for the other. And if you look at this, that method is the fastest. The reason is simply because we can transmit and receive simultaneously without need to wait for somebody to finish. And a typical example of where this is applied is in telecommunication systems, where as you are speaking with somebody now, he can also be speaking to you. He will be hearing you and you'll be hearing him at the same time. So these are the three modes of data transmission. We have seen the types of data transmission, which include serial and parallel, and under serial we have synchronous and asynchronous, but the modes are three: the simplex mode, half duplex, and the full duplex. Now we move to another segment, which is error detection and correction. As we know, whenever we are sending data from the sending end to the receiving end, there is every tendency that a problem can happen to the data in such a way that it can have an error. Now, what is error detection then? The error detection is the process of detecting errors which are caused by noise or other impairments, that is other problems during the transmission of the data from the transmitter to the receiver. If we say noise, we mean any information that comes into the data that is not needed. So whenever this information enters the original data, it can cause an error to that. And if we talk about error correction, we are saying the process of reconstructing the data that has error in such a way that it will come back to its original form that does not have any error. Now, the error detection schemes, that is, what are the different methods we use for detecting errors in computer data transmission. Number one is called repetition codes. Repetition codes. By repetition, as we know, is to do one thing more than one times. And in this way, each block of data we are transmitting from the transmitter to the receiver, we send it some number of times, so that if all of them arrive accurately and the receiver see them, they are the same, then it knows there is no error. For instance, if you want to send these bits 1011, you want to send it from the sender to the receiver, you can decide to send it like 3 times. Send this one, which is the actual data, send it again, and send it again. How many times? You send it 3 times. So now, when at the receiving end, we get something like this. Look at them. Here I have 1010, but this one is 1011, which is the original data, and this one is 1011, which is the original data. So now the receiver will know that the first one is different from the other two, and this is a signal that shows that yes, there is an error because the first one is different from the others. Now, if it is able to know this, then it has done what we call error detection. Then this method is insufficient. Why is it insufficient? This is the reason. Supposing we sent this data 1011 1011 1011 3 times. But when they arrive at the receiver receives something like this: 1010 1010 10. You see, all the three are the same, but they are different from the originally sent data. So the receiver cannot know that there is an error because all of them have the same type of error. So therefore this method has a disadvantage, because when error occurs in all of them and they have the same pattern, then the receiver will never be able to know that an error has happened. And the advantage of this repetition code method is that it is very simple, extremely simple. Then another method of detecting error is what we call the parity bits. This parity bit is nothing but a method of adding some number of bits 1 to a data in such a way that the total number of ones in it should be even number or odd number. Therefore we have two types of parities. We have even parity and we have odd parity. And for you to understand this, let us assume that we are dealing with, let's say, even parity, and I have a data like this. Let's say I have a data like this. If you look at this data, how many ones do I have? 1 2 3. So when I'm doing even parity, what I will do is that I will take this data, which is the original data I want to transmit, and then add another one to it, add another one to it, add another one to it like this. If you add one here, you can now count that here I have 1 1 1 1. How many of them? I have 4, and 4 is an even number. Okay, but supposing I am doing odd parity, I'm doing odd parity. So if my original data is this, you can know that how many ones do I have here? 1 2 3, which is odd number. So I'm going to add 2 ones so that it will maintain that odd number, because adding 2 ones will still make it 1 2 3 4 5, which is an odd one. Therefore adding some ones into a data so that the total number of ones can be even is called even parity, and adding some ones to the original data in such a way that the total number of ones should be odd is called odd parity. Okay, now this method is very simple also. It is very simple, because if you want to detect single parity or any number, you just add those number of ones. I hope you understand. Let me say it again. Supposing I have something like this. I'm doing, let's say, even parity. Here I have 3 ones. I told you I'm going to add another one to give me 4. Therefore they are even. So when this data is sent to the receiver, all it will do, because it knows that we are using even parity, it will check how many ones do we have. 1 2 3 4. So if there are 4, it will say okay, the data received is correct, and it will remove the parity bit added and take the remaining as the original data. But if we are doing odd parity, but in a situation where it received the data, instead of seeing 4 ones, it received, let's say, 3 ones, it knows that there is a problem. Or it received 5 ones, it knows there is a problem, because it is supposed to see even number of ones, but we are seeing odd number of ones. And the disadvantage of this problem is that whenever you have even bits change from 0 to 1 or 1 to 0, the receiver cannot detect the error. Let me explain what I'm saying. I told you my original data here exclude this last one. It exclude this. We have how many ones? 1 2 3, which is odd number. And if we are doing even parity, I told you we should add another one so that the total number of ones should be 4, which is an even number. But assuming when the data is received at the receiver, it found that this one, which is originally 0, changed to 1, and then maybe this one also, which is original 0, change to 1. Now if you count, you see that 1 2 3 4 5 6, still I have even number, because the receiver knows that we are using even parity. It will say yes, the number of ones still they are what, even number, so therefore it will assume there is no error. Therefore this is the disadvantage of this method. Now another method we use for detecting errors in data transmission is called checksums, and this checksums is done using what we call a modular arithmetic sum, the message code. And how do you do that? What you will do is that you the sum you are sending to the receiver can be negated, that is, can be made negative. And how do you make it negative? By doing what we call ones complement operation before you send the data to the receiver. And what the receiver is expected to do is to detect errors which result in all zeros. When all the message sent, everything is 0, it will say there is error, but if not, then there is no any error. Now another method we use for detecting errors in the data we send to the receiver from the transmitter is called cyclic redundancy check, and this one is designed for finding out, for detecting accidental change in the data. Therefore this method is not suitable for detecting maliciously introduced, that is, intentionally introduced error. But if the error occurs accidentally, it has the ability of detecting it. And how do? We use what we call generator polynomial, this mathematics. And this generator polynomial is used as our divisor, that is the polynomial that will be used for dividing. And the input data we are sending to the receiver is used as dividend, that is the data that is being divided by the divisor. And we do this division using what we call a long division methods. Then the remainder, if you say the dividend divide by divisor, you will get a result, and that result is your remainder. Okay, so now you send that as your data, and at the end of the day it will now carry out multiplication to reconstruct the original data. This method is very easy to implement in hardwares, like in digital networks, like in hard disk drives and other hardware equipment of a computer. Now we have seen different ways of detecting error in data transmission in computer, from one computer to another. So the other segment here is error correcting codes. How do we correct an error if we detect that it occurs? And we have different methods also here. One of them is called automatic repeat requests. This automatic repeat request is a method of correcting error in such a way that when the receiver receives an error and it detects that there is an error using those methods we discussed, it will now automatically send back a request to the sender that sends another signal, because the one I received is in error. And it works using what we call acknowledgements. That is, whenever the receiver receives the signal, it can send positive acknowledgement telling the receiver that what I got is correct, or it can send a negative acknowledgement telling the receiver that there is an error in the data I received. That's what I said. The positive acknowledgement indicate that the data frame received is correct. But if there is no acknowledgement at the same time before the time is out, the transmitter will now send the data again, because it knows that there is a problem, and it will keep on sending as far as there is no acknowledgement until it goes beyond some set time. Maybe it is programmed to send 10 times. Once it finishes that without acknowledgement, it will stop sending. And this automatic repeat request has different methods, different protocols. Number one is called stop and wait automatic repeat request. The other one is called go back n times, and the other one is called selective repeats. And for us to understand this, let me shed more light on it. This stop and wait is the one in which whenever the receiver receives the data, it is expected to send back acknowledgement. If it does not send, the transmitter will wait for some time and then resend the data. And go back n times, it is the one in which the receiver will keep on sending the data up to the number of times programmed. And this selective request or repeat is the one in which it is not all the frames of data that are repeated by the transmitter, but it will select some of them and resend them to the receiver. Now there is another method apart from the automatic repeat request, and this method is called the forward error correcting code. And how does it work? It works by adding some redundant or parity data to the original message it is sending, so that the receiver will use those redundant data added to it, and it can use this redundant data added to it or the parity data sent to it to be able to know that this error has happened. Then this redundant data will be used for correcting the error, which means as the transmitter is sending the data, it will send the original data together with the data that will be used for correcting any error in case it happens during the transmission. And either during the transmission or at the storage, the error can occur, so we can use that redundant data or the parity data in order to correct the error. So if you look at this, it means the receiver don't need to separately send another correcting or another signal again. Then in this case, if you understand it very well, it means we don't need a back channel, we don't need any feedback channel, because we don't need the receiver to request for resend of anything or for transmitter to send another thing. Therefore there is no need of feedback channel, that's back channel. Also, this method is very suitable in simplex mode of transmission data, such as what broadcasting, because I told you in simplex mode you send the data but the receiver cannot communicate with you. So in that case, you send your forward error detecting code together with the data, so that in case when error occurs, we can use that the redundant data or the parity data you send for correcting, because there is no way the receiver can send back to the sender to make the corrections, because there is no that channel. And it is used mainly in storage media, such as in CDs, in DVDs, in hard disks, and the RAM. These are devices for storage in computer. Then there is what we call a hybrid scheme. Whenever we mention hybrid, we are talking of combination of more than one thing. So the hybrid scheme is a combination of automatic request, repeat request, and the forward error correcting code. Combination of the two gives what we call the hybrid scheme. And this hybrid scheme has two basic approaches. Number one, we use what we call always transmit with forward error correcting code and the parity data. Whenever it is transmitting, it will transmit together with the parity data that will be used for correcting the error in case it is detected. And that data, the parity data we send, is called a redundant data. The receiver will now decode the message it received using the parity information, and in case if it detects that there is an error that the parity information or the forward error correcting data cannot correct, then it will now automatically request for the resend of the data. So if you look at this, it's a combination of two things. We send with our forward error correcting data, and at the same time, when this error correcting data cannot correct the detected error, the transmitter can send the request for automatic resend. So for this, you can see it's a combination of two things. Then the second one is transmitted without any parity data. It is only sent with error detection information. That is the data that the transmitter will just use to know whether there is error or not. So in case if it detects there is error, then the receiver will send automatic request for the transmitter to resend that data correctly. This is what we call hybrid schemes. And all we have seen under error detection and correction. Where do we use them? In real life computer systems. We use them in internet communication. We also use them in what we call deep space telecommunications, that is astronomy, and it is also used in satellite broadcasting, and we also use them in data storage in computers. So ladies and gentlemen, this is the end of our lecture number 3 of Buad718 Computer in Organization. I would like to thank you for your time watching this video, and as usual I would like to conclude by advising you once more that please take your time, get a quiet place, play the video, listen attentively. You can be pausing it from one time to another so that you grasp the information being delivered, and I advise you to play it several times so that you can master and understand what is explained here. And in case you still have problem, please do not hesitate to contact me. I'll try to shed more light, and you can as well contact some of your friends who are also capable of helping you get out of your confusion. Thank you very much, and we meet in lecture